Here we are at the Piaggio Avanti 2. It's a very unique looking aircraft, as you'll see as we do the walk around here. Move forward on it. What makes it most unique is the forward wing. Not a canard, it's an actual fixed wing with fully integrated flaps. The wing is cut out of a solid piece of aluminum and bolted right on to the nose. Come around. Your nose bay here, you can see the screws. This comes off. That's where all your avionics are housed. Stack of about 8 different computers in there. Runs all the instrumentation, obviously, the Proline 21 that we'll show you inside later. Around. And the other forward wing. A static wicks attached to the wing. Come around here. There's a nose wheel. The nose wheel's got a pin, we'll talk about in a little bit, for steering. The nose wheel goes off of a hydraulic power. Very interesting, unique little piece right here. This is for our anti-icing. This is actually a sensor that runs off of harmonics. It vibrates at a certain frequency, just like a tuning fork. And when ice hits it and builds up on the probe, it changes the frequency, it changes the actual pitch, which then sets off a light in the interior. Little drip in there, we have the AC going on the inside. Emergency hatch, you'll see it from the inside too. It's a plug that goes in, sets aside. This is for RVSM, which is reduced vertical separation minimums. And I think it was 2005, the FAA decided between 29,000 feet and 41,000 feet, flight level 290, flight level 410. It used to be that the aircraft had to stay 2,000 feet apart vertically. After that time, they decided with some additional equipment, which is inside these areas, inside under the skin of the aircraft, they could actually reduce the vertical separation to 1,000 feet, fitting a lot more traffic into that area. Static ports here. Again, familiar with the pitot-static system on an aircraft. It's similar, just there. Angle of attack probe. Lets us know it rolls back and forth. Gives an indication if we're entering a stall with the aircraft, stall in the wing. Down here we've got main gear. It's pretty beefy gear. It's similar to some of what the Italian military uses on some of their fighters. Very rugged. I've never had an issue with any gear. Make sure we can go under here a little bit. Refueling, single point fueling. Now, external panel here, which is used for the fuel. We have an interconnect switch that opens between, so the two tanks, this left and right tank, will fill evenly. You can check your systems here. Left and right engine oils. This is where we actually check them here instead of using a dipstick. The flashing is chip detectors. If they're flashing, the chip detectors are working properly in the engine. So, hydraulic filter. Hold it down, you get your hydraulic level light. Hydraulic filter goes out. It takes about 10 seconds or so. There's an optic sensor that's looking at the level of the hydraulic fluid, and then it goes out when it's proper. Work our way back to the front here. Engine nacelles here. Piaggio, the Avanti 2 uses the Pratt & Whitney. It's a PT6A-66B model. The engines are 850 shaft horsepower. The initial engine is 1,400 horsepower, and then they flat rate it down to 850. At around 2/3 throttle, I'm developing full power on the engines. This allows me, as I climb into the thinner atmosphere, I can increase the throttles and increase, and I can maintain that 850 shaft horsepower up to about 25,000 feet. Then the internal turbine temperatures take over, and they max at about 830 degrees Celsius. So I like to run the plane at about between 800 and 810 ITT when we're in the mid-30s. 30,000 feet. The Piaggio can cruise at roughly 400 knots. Max is 405 knots, and I like to pull it back a little bit, and we cruise probably between 380 and 385 knots. So fairly quick, for a turboprop. It is considered the fastest commercially built twin-engine turboprop in the world. When you look at the whole shape of the Piaggio in itself, the fuselage is actually shaped like a wing. We get about 20% of our lift just off the body of the aircraft. The forward wing gives us 18% of the lift. That allowed the engineers to decrease the main wing by about a third of its normal size. Putting all this together, we reduced a lot of the induced drag on the aircraft. So, you'll see the tail is a full T-tail. Unlike your conventional aircraft, which has an inverted wing, if you will, most conventional aircraft produce lift on the bottom of it, which pulls the tail down and holds the nose up. Piaggio was able to, with the forward wing, use positive lift to hold the nose up. So when we're in flight, the tail actually goes to roughly zero lift. So we're not producing any negative lift, which also produces induced drag. So they were, through about 5,200 hours of wind tunnel testing, they were able to really clean up the aircraft. If you look at the aircraft again, you look at the skin of the aircraft, it looks like a composite material because it's so smooth, but it's not. The whole fuselage and the wings and most of the tail is aluminum. There's a few pieces that are composite. The engine nacelles are composite. The strakes on the bottom are composite, and a few pieces of the tail. Really, that's about it. It looks like a composite type aircraft, but it's not. The leading edge here is stainless steel. What Piaggio has done with it's called a laminar flow wing. And the laminar flow wing, literally, it has to maintain very clean wing. So what they've done is filled in any of the grooves and then painted the whole wing. So with our anti-icing system, we use bleed air off the engines to heat the leading edge of the wing. You'll see it on other aircraft. The stainless steel, that's kind of a giveaway that it has that type of a de-icing system or anti-ice system. The forward wing is electrically heated. The propellers, as we'll see in a minute, are in the exhaust flow and do not need any heating at all. So let's keep walking around the wing. Really standard lighting system. A lot of different static wicks on it. Got a flap system. Here. Got fire bottles in here in case of an engine fire. We have a button on the inside we can actually push, and an extinguisher will extinguish the flame. Piaggio decided to go with 5-bladed pusher props on this aircraft. They originally tried jet engines and didn't get the performance that they wanted. So the 5-bladed pushers, they're in the back as a pusher because of that laminar flow wing. They want to keep that wing, just the airflow over that wing, as smooth as possible. If the wing is dirty with a lot of bugs, we can actually lose 2 or 3 knots in the air. Piaggio holds about 420 gallons of Jet A fuel. Allows us to go approximately 1,400 nautical miles and still have your legal reserves of fuel left over. We burn between 90 and 100 gallons an hour, which is extremely efficient for the type aircraft at the speed that we get. Again, we've got our single point there, and Piaggio also decided to put in a gravity feed up top because we can get into a lot of smaller airports that a lot of aircraft don't go, and they might not have Jet A or a single point connector. They can actually climb onto the wing and use the gravity feed on top to top off the aircraft. Empennage, full T-tail system we talked about. Again, goes to about 0 lift when we're in the air. Full rudder, standard. Work our way around. Coming to this side. The luggage compartment is in the rear, external. Take a quick look in. It's about 40 square feet. Pretty good size. This houses the battery, some other equipment. Air conditioning Freon system is covered there. And we can work our way back around. Here on the port side. Inside the left wheel well is the hydraulic pump. It's mainly an electrical aircraft. The hydraulic pump itself is only used to run the landing gear, the braking system, and the nose wheel steering. We can hook up external power here, a GPU, a ground power unit, and we can plug in and run all the equipment on the aircraft without running down the battery. Again, the RVSM area for the left-hand side, static port. Take a look at the inside now. The door itself has got two separate seals in it that inflate for pressurization. And we have indications up front whether, even if one seal is not inflating properly, we'll get the light illuminated in the cockpit. Now here we are on the inside of the Piaggio, in the cockpit. We can go over some of the instrumentation here. We've got a full flight management system down here. Put all of our flight plans, everything. I've actually got a flight plan from Miami right now. Read all of our different waypoints. So moving up, we can look at the initial instrumentation is the Proline 21, made by Collins. Very high-tech equipment. Let's see. Three displays. This is your primary, your PFD, primary flight display. The MFD in the middle is a multi-function. We can do several different things on this. Coming over, we actually have a whole way to check all of our systems. Up here we have a reversionary panel, where we can literally take this information and place it over here. If one of our screens actually fails on us, we can take it and send everything over to the PFDs and bring it all back. And if any of the main screens fail, we can actually put all the information on the MFD. So a lot of good redundant sources. Bring it back. Here we have what's called a EPU, emergency power unit. If everything else fails, dual generator failure, this unit here has a 30-minute battery that will give us all our information from airspeed to attitude to vertical speed. We can actually fly the whole aircraft just off this one instrument. We'll also power up the gear to know if your gear are down and locked, and emergency lighting. Runs for about 30 minutes. The Piaggio is laid out nicely as far as a single pilot. You look down, everything is in reach of the left seat. Everything's grouped together nicely. We have communication down here. Then we actually have cabin utilities in the back to run a lot of the equipment we have in the back. The cooling system is here, heating, bleed air, your hydraulic pressure, gear switch, emergency brake. So your whole landing gear is here. Anti-ice is all here. The system test we've already talked about here. And then the whole cabin pressurization system is here. Coming down the center, all your master switches here. Your fuel switches. Your engine and propeller switches, ignitions. Auto feather. And of course your power levers. These are actually fuel cutoff levers and propeller levers. So we control both with the same lever. Flaps are here. And then our whole lighting system is here. Moving down the pedestal, you have the FMS again. Coming down, we actually have other ones where for different charting. And then our trim panel. With the Proline 21, we can actually hit chart and pull up any chart available. Let's put in, here's the airport for Miami. We picked up Miami. Processing. And here's the whole Miami airport layout. We can also have an ILS for runway 8 right in here, so our approach plates are in. There's no more looking in the books and trying to pull out an approach plate. It's all right in front of us. They're very good situational awareness. They actually have an aircraft will fly onto the screen and show our exact position and then track in as we're tracking it on the ILS, Instrument Landing System. We actually have, might pull up, here we are. We have XM satellite radar on board. We can zoom in anywhere on the US. Zoom in. There's a pretty good storm going on in the northern part of Wisconsin right now. And you can zoom in again, another storm in Missouri. And again, the airplane is overlaid on the screen so we can actually see the radar in front of us. And this is, as I said, satellite radar. We also have onboard radar, and between the two of them you can literally pick your way around or through thunderstorms, through a line of thunderstorms if you need to. Moving up, this is the autopilot panel. Everything dealing with automated flight. Autopilot, we have vertical navigation. I can once again in the FMS, if I'm told to cross a waypoint at say 6,000 feet and I'm currently at 37,000 feet, I can down in the FMS enter in the altitude that I want to be at that fix, 6,000, and then just press VNAV. VNAV will arm on your multifunction display here. You see V-pitch. VNAV is vertical navigation. So V-pitch is armed now. When I reach a certain point on my chart, a TOD will appear, top of descent. The aircraft will give me an audible 2 beeps and will literally start down on I have a 3% glide path set on this. It will start down on a 3% glide path to intercept the 6,000 feet at that fix. Piaggio does not have auto throttle, so I do have to bring the throttles back in order to slow the aircraft down so we don't overspeed. On the left-hand wall, we've got the interior light switch so that the pilot can control the rear and the front. You've got your quick donning mask. This is the oxygen bottle, which supplies the oxygen to the mask. Over here, we hang our headsets up over here. I decided to put the Bose in this one. The Bose noise canceling. It's extremely quiet in here. A little flexible light for reading your maps at night and that sort of thing. On the yoke itself, you've got a master disconnect, which will disconnect all of whatever you've got as far as steering and this sort of thing. There's a nose wheel steering on the aircraft, where once I engage it, you can see on the PFD, steering is in takeoff mode now. If I push it down halfway, it goes to steering taxi mode. Steer taxi mode. If I hit the master disconnect again, it disconnects my steering. All right there at easy reach of your thumb, just in case something happens and the steering screws up. The steering itself is freewheeling. There's a pin that holds it in place. If I pull the pin, you can actually rotate the main wheel. You can rotate the nose wheel 360 degrees. There are 2 potentiometers that actually talk to each other, the top and bottom, that tell you if the nose wheel is lined up properly. Then this is a full trim button here. Move it up or down. You can actually see the trim moving on our pitch trim here, so we can tell where we are. And this is just a synchronizer switch here. I can hit it, and my flight director, which was up, will sync in with my command bars. And this here's just a timer. So this nose wheel steering is only on the left-hand side. Everything else for the co-pilot is identical except for nose wheel steering. It comes equipped with a couple of different types of glare shields, which can be completely adjustable. Very handy when flying straight into the sun. And also on the side, we have little screens that can pop up. So, interior lighting, speakers. Different grab bar handles here are made for entering and exiting the cockpit. We've got a little courtesy curtain, if you will, for privacy. The cabin is pretty spacious for the category aircraft. Let's see, we'll start up front here. It's got a good sized club chair facing forward. There's different configurations for different Piaggios, but we have a divan here to hold 2 people. This is an emergency hatch right here that will come in if needed. Down we've got air cell, satellite phone. There's all sorts of different drawers for storage. Fire extinguisher. Back again, everyone has their own control for air and lighting above. And moving toward the back, we actually have full, just more storage space. We'll keep a little cooler in here with ice, keep some coffee pots and that sort of thing. So, take a look at the back now. The aft cabin is set up with 4 club chairs, very comfortable, very large chairs, once again, for the category aircraft it is. The cabin itself in the back is approximately 5 feet 9 inches high, with about 6 feet 2 inches wide. So the interior, compared to other aircraft, is what really sells this aircraft. The comfort in it is what really sells. So we have full tables here. The chairs recline, and the chairs will actually move out also onto different positions. You can set whatever you like, whatever position. This one here will actually spin around in a 180 and can face forward. On this particular one, we put in a main screen back here, which you can run movies on or see the different flight times displayed. We put 2 additional ones on the side with full XM radio, different controls. And up front, there's an actual drop-down screen in the ceiling. In the back, there's a fully belted potty. It's a legal seat. This type configuration can hold 8 passengers and 2 crew. Has a full closet, hanging space. The bathroom can be completely closed off instead of just a curtain. It has a full door. And again, more storage space in the back, top and bottom. The door is similar to a Lear. If you look at the original Avanti 1, the cockpit was laid out like Lear. What a lot of people don't know is that it was Lear Gates that started developing the Piaggio in the United States back in the 80s. Became a joint venture with Piaggio, and then Piaggio purchased it and moved it over to the rest of the production over to Italy. It was in the 90s, they'd only made a few, and they started going bankrupt. So the Italian government stepped in and asked Ferrari to take over management of the company. And Ferrari is still part owner in it. They've sold off some shares to different companies, but if you look around, you'll actually see a lot of Lear type designs in the Piaggio.